Felt like in class I wasn't really, I didn't show you maybe the easiest way to go about these. So here are the solutions. You can find these on my website. These are, Mr. Chase drew these up. In the examples we did, I told you acceleration was going to be constant. You can see that in some of these, acceleration's not. We've got little curves over there, curves on the velocity, but that's okay. I won't give you problems where acceleration is not constant. So I think the easiest way really to go about this is to think about slope. Remember that the slope of this, so the slope in this graph equals acceleration, and the slope in this graph equals velocity. And that's really, I think, all we need to know. So looking at this one, first we start out with positive velocity and a zero slope. So if the slope is zero, then the acceleration is going to be zero. I'll just go from there to there. Then the velocity goes down to some negative velocity, and it looks like the slope is zero again. So the acceleration is zero. Now something happens right here. This is I don't know if this is angled, but it looks like it's straight up and down. This is impossible. The slope here, if you do rise over run, it's infinite. So and the velocity is changing from a positive velocity to a negative velocity. So we've got infinite negative acceleration. So I would draw it like this, somewhere down here. It's kind of, I don't even know how to draw that, so maybe I'll just make it trail off. There's probably some sign in math for this going forever. So the acceleration is constant, then infinitely negative, and then constant again. It's kind of a weird one. Now on this, I need to have slopes that give me these values. So since the velocity is constant and positive, I need a constant positive slope in the first half. So in this time period, we need to have a constant positive slope. So that can look like this. And then in the second time period here, we have a constant negative velocity. The velocity here, this is zero, so velocity is in the negative region, and the velocity stays constant, so I need a constant negative slope. This next one, starting with this, I'm looking at, this one's a little easier because I can just go left to right. So what I've got is a straight line here, a constant negative slope. Then from about there to there, I've got a negative slope, but it's getting less negative. And then I have zero slope. So if I sort of divide this time period up into this and this, first part is going to be, remember the slope of this gives me that. So this is all constant and negative. So I've got a constant negative velocity. And this part, I have no slope at all, so I have no velocity. Then in this part, I've got a negative slope, but it's getting less negative until it sort of fades into no slope at all. Strong negative, weak negative, then zero. So the velocity is going from negative, pretty large magnitude negative, to smaller magnitude negative to zero. So now I look at the slopes I've got here, and that gives me acceleration. Here there's zero slope, so in this first part there's zero acceleration. Now there's positive slope, that means there's positive acceleration. Zero slope, so zero acceleration again. And that looks a little different than the way it was drawn on here, but same basic thing. Acceleration zero, acceleration jumps up, acceleration goes back down. All right, I got to work backward. I can either go from here to there or there to there. I'll do this one first. So velocity starts negative, which means my slope of this needs to start negative. And the velocity becomes less negative until it gets to 0, which means the slope needs to get less negative until there's no slope. So it's going to start out going down. I'll just start it from up here. I could start it anywhere. I could go like that. I could go like that. I'll start from the top. So I've got a negative slope. And now it's going to get, until about this time right here, I want it to get less negative. And at about this time, the velocity is 0. So the slope needs to approach 0 about right here. There, I've got this part taken care of. Now the velocity is positive, and it's getting more positive, which means the slope needs to be positive and get more positive. Right here, the slope is 0 still. So the slope is 0. Slope is going to start, this slope is going to start growing because this velocity is growing. And it's going to be positive because this velocity is positive. So I start out with, it's going to be kind of like that. So I've got 0 slope here because there's 0 velocity. A little bit of positive slope because there's a little positive velocity. More positive slope because there's more positive velocity. Now with acceleration, acceleration is the slope of this, and the slope of this is the same the whole time, and it's positive the whole time, so this is constant positive acceleration. This, let's see, it looks like when I have straight sections and curved sections, I think it's kind of helpful to divide this into the curved part, the straight part, and maybe I'll break up my time periods and all these this way too. There we go. So, velocity. I'll do the acceleration one first. I could do that one first. The velocity is the slope of the velocity graph. Remember, slope of velocity versus time gives me acceleration. And the slope of distance versus time gives me velocity. So if I look at the slope of this, the slope is constant and positive. So that means acceleration is constant and positive. This last part, the slope is 0, the acceleration is 0. Here the slope is positive, but it's getting less steep, less positive until it's going down to 0. So basically that's happening. Now working backward here, I think this might be a little harder to work backward. So this tells me the slope of that. So really what I'm doing is looking at this region here, and I'm noticing that velocity starts at 0 and it goes up to some number. So that means the slope of this is going to start at 0, and it's going to increase because velocity increases, and it should stay positive. So I'll start it out like this, and the slope is level, but now it's going to be a little, velocity is a little bit higher and positive, so the slope's going to be a little higher and positive. Velocity is even higher and positive, so the slope's going to be higher and positive. So this is going to curve up until that moment right there, which I'll say I've reached. Now the velocity is going to keep going up, so and then it's going to eventually stop going up right here, and then it's going to stay constant. So let's see, let me do this part. There's no slope here, so it doesn't matter whether there's slope here. That only affects this one. Velocity is constant here and positive. So when I get to this region, I'm going to have a straight line with a positive slope, and it's going to be the greatest slope of all. So I can see a problem here. It looks like this is going to have to go way up, so I'm going to make this a little lower. I can maybe even work backward. So this is going up like that, and at the very end here it's got to be straight. little troubled with what to do in between there. So velocity is increasing, still increasing here, but increasing at a lower rate, and then it only stops increasing there. So I guess the curve is a stronger curve here, and then it's kind of a weaker curve through this. This is a weird one. And then it's important to note that right here I could get a straight edge and draw it. This should be a straight line. This should be a really small curve because velocity is increasing less and less. And this is a really strong curve because velocity is increasing fast. So that's a weird one. And here's the solution that was given. Alright, this looks pretty simple. So we have velocity decreasing the whole time at a constant rate. Remember, the slope of this is the acceleration. The slope is negative and constant, so acceleration is negative and constant. And the slope of this is going to be velocity, so the slope is going to start out positive. Here's zero velocity. It's going to start out positive, and then the slope's going to get less steep, less steep, less steep until there's no slope, and then the slope is going to get steeper and steeper and steeper and steeper. This actually looks like a ball thrown up in the air. This is, let's just say this is 5 meters per second, and this is 5 meters per second. So if you're standing on a cliff like this, and you throw a ball up, and then it goes like that, it's going to be going 5 meters per second, slows down to nothing, speeds back up to 5 meters per second, and then keeps speeding up. And that's what this is going to do. It's going to go beyond, negative 5 meters per second. So I got distracted there. The position, so the slope of this graph needs to be positive and get less and less and less positive, and then it needs to be zero about right here, and then it needs to be negative. So I'm going to do zero slope there. This is going to look like a curve, like this. So positive slope getting less positive, zero slope right here, negative slope getting more negative. All right, acceleration, positive acceleration until this point in time. So that means we need to have a positive slope on velocity. I can make it a positive velocity that's growing, or I can make it a negative velocity. So this could go, I'll just make it like this. I'll start with zero velocity. I would go up, and then zero acceleration there means zero slope here. So the slope of this, the slope of this gives me this. So my slope needs to start, for this graph, needs to start at zero and increase and increase and increase to some particular point and then stay the same. And it should be positive the whole time because the velocity is always positive here. So I'll start at zero. I could do it there or there, start it here. Increasing slope, increasing slope, increasing slope until I get to about right there, and then same positive slope the whole way. This one, I'll do that first. So I've got positive velocity the whole time. That means positive slope the whole time. Starting out with a pretty big positive slope, and then I have a decreasing positive slope until I get to zero. So I guess no positive slope there. So I'm going to start out with a big slope and constant slope until I get about this far along time-wise, like that. And then the slope is still positive, but it's going to decrease until about right here, and then it's going to be zero. So it flattens out there. It's different than what's on here. This one just doesn't show as much of a I like mine better. Okay, and then acceleration, velocity. So going from here to here is easy. We just look at the slope of that. The slope is 0, so the acceleration is 0 until about that point in time. And then the slope slowly starts to become negative. It gets more and more negative until about there. And then it stays at the same negative slope from here to here. So these are my 3 little time periods. This last time period, slope is negative and constant, so acceleration is negative and constant. Through here I'm going from 0 slope, where I have 0 acceleration, to this negative slope, so it's going to be something like this. Last one, velocity is increasing at a constant rate, so acceleration is positive and constant. The constant slope here means constant acceleration. Constant negative slope means constant negative acceleration. So the slope of this graph needs to give me these velocities. So in this first half, I need to start out with 0 slope here because the velocity is 0. And I need to work up to a slope that is positive. It's going to be positive the whole time and most positive there. So I'll start out here with 0 slope, flat, and it's getting more and more positive until I get to here. And that's the steepest part. So this is steepest when this number is biggest. The steepnesses of these two aren't necessarily the same. Now this number starts to get smaller, which means this gets less steep. This is still positive, which means this is still positive. But the steepness is going to go down to right there again, no steepness at all. So I need to get less steep, less steep, less steep, less steep until there's no steepness at all. So the slope there is 0, slope there is 0, because velocity there and there is 0.